Alright, so number 4, this is number 4. Domain is x such that x cannot be -1 because that makes the denominator 0, that x value. No holes because there's no common factors that cancel. X-intercept, what makes the numerator 0 is 1, so it's 1, 0. Y-intercept, you cover up the x's and you're left with -1/1, so that's 0, -1. Vertical asymptote, again, you could either look at the denominator or look at your domain, and it would be x equals -1. This one's powers equal, so it's a horizontal asymptote with y equal to 1/1, which is 1. Because remember, we look at the leading coefficient of each of the numerator and denominator. This one is no symmetry because replace the x with a -x and you do not get the original one back, f of x, and you do not get the opposite of it back. So it's none. So let's go ahead and draw the asymptotes. So I went ahead and drew the asymptotes and the 2 points that we have, the 2 intercepts. So I know that on the right side, the right branch is already, ready to go. I've got 2 points. I'm just going to connect them with a curve and go towards the asymptotes like this. On the left side, because I know that the graph is never going to intersect the x-axis again other than right here, I know the branch cannot be here. Okay, so I know it has to be up here somewhere. So I'm going to use, let's say, -2 to get the exact point. So f of -2. So -2 minus 1 is -3, and -2 plus 1 is -1, so that gives me 3. So the point is -2, 3. Okay, so there I'm going to draw -2, 3. Okay, and with that, just draw your curve, and we're done. Alright, for number 5, there's nothing to factor. The denominator has no real, doesn't have any zeros, so the domain is all reals. The holes, nothing to cancel, no common factors, so no holes. X-intercept, none, because you cover up, there's nothing in the numerator that makes it 0. The y-intercept, cover up the x squared and you get 12/2, which is 6. So it's 0, 6. Vertical asymptotes, none. Horizontal asymptote, it's a bottom-heavy function, so it's y equals 0. As for symmetry, I know that when you replace the x with a -x and you simplify, you get the same function back. So this is an even function. So again, remember it's symmetrical with respect to the y-axis. So I went ahead and I drew the information, what I got, so the asymptote and the point. And I know that the asymptote, the horizontal asymptote, serves the purpose of telling us what the end behavior is. So I know that the function, as I get close, more to the left and more to the right, the function is going to go towards the asymptote in both directions. I also know that it's an even function. So whatever I get here, I know it's going to reflect over here exactly in the same, it's over the y-axis. So let me go ahead and pick, let's say, f of 2, just to pick a number. So f of 2, so I get 12/2 squared is 4. 4 plus 2 is 6, so that gives me 2. So 2, 2. So I have a point right here. And so I know I automatically have a point right here because it's symmetric with respect to the y-axis. So that's enough to kind of connect them and then go towards the asymptote and towards the asymptote. And that's it. Okay, so let's go ahead and factor the numerator. So that's 1 minus x, 1 plus x, all over x. The domain is all x such that x cannot be 0, because that's what makes the denominator 0. No holes because there's no common factors. X-intercept, we have 2 of them, plus and minus 1, because those numbers make the numerator 0. Y-intercept, none, because remember x cannot be 0. We have that from the domain, so none. Vertical asymptote, we have x equals 0. Horizontal asymptote, this is a top-heavy polynomial. Polynomial function, I mean. So for this, we have to do the division. So x, let me put it here, x, put it in standard form, so it'd be negative x squared plus 0x plus 1, because remember you need a placeholder. So x goes into negative x squared, negative x times, then you subtract, so that means adding the opposite, and you bring down 0x, but 0x is 0, right? So that's it. The remainder is 1. So we don't care about remainder, remember? We only care about the quotient, so negative x. That's your your slant asymptote in this case, or oblique. Same thing. As for symmetry, this one is when you replace the x with a negative x, the numerator is the same and the denominator is the opposite. So this one is going to be an odd function because you get the opposite of the original. So this one's going to be symmetric, with respect to the origin. Okay? Alright, so I went ahead and I drew the asymptotes, the vertical one at x equals 0, the oblique one or slant at y equals negative x. I already have those 2 points there, the 2 intercepts, and that's all we need. Because remember, the vertical asymptote divides the graph into 2 pieces. We're going to have a piece on this side and a piece on this side. Now, there's a top half and a bottom half, right? There's a top half and a bottom half. And so I already have a dot right there, so I know that the right side is going to go this way. And the left side, I have a point right here, it's going to go like this. And that's it. So I'm going to just go ahead and draw that. So towards the asymptote, same thing on the left side. Whoops, towards the asymptote, and towards the asymptote. And that's it. So I'm going to go ahead and factor first, so x plus 4, x minus 4. In the denominator, factors of 8 that add up to negative 6, x minus 4, x minus 2. Okay, my kids are home, so hold on. Alright, so 7 is factored domain. We look at the denominator. So it's all x such that x cannot equal 4 or 2. Okay. Wholes, well, this time around there is a common factor right here. And so we know that there's a whole at x equals 4 because 4 makes that factor a 0. So we cancel it out. And the x coordinate is 4. To get the y coordinate, you just replace the x's that are left with a 4. So 4 plus 4 over 4 minus 2. And I'm looking at this one and this one. So 8 over 2, so that gives you 4. So that's where the whole is going to be. X-intercept, you look at what's left and at the numerator, and what makes the numerator 0 is negative 4. Y-intercept, you cover up your x's, either the ones that are left or in the original one right here, you can just cover this, this, and this, and you're left with this. That's negative 2. So 0, negative 2. Vertical asymptotes, okay, remember we cannot count the 4 because that's a whole, but we still have a 2 there in the domain, so x equals 2. This is a powers equal function, so it's y equals a over b, which is this over this, the coefficient here and the coefficient here, which is 1 over 1, which is 1. As for symmetry, this one has neither, none, it's not even, it's not odd, because the numerator would stay the same, but the denominator would not be the same as the original, nor would it be the opposite of the original. So this is none. Okay, so we go ahead and draw the asymptotes and the intercepts. Okay, so I went ahead and I drew the asymptotes and the two intercepts along with the hole right here, and I made it really obvious that it's a hole. And here these are two dots. Okay, so we have enough on the graph that we don't need to figure out any other point. So with the two dots on the left, I'm just going to connect them with a smooth curve going towards the asymptotes. On the right side, same thing. I'm just gonna from that hole, I'm just gonna draw the branch, and that's it. Alright, so number 8 is factored already for us, and I usually like to have the other version on there, the multiplied one, because that way you can, when you find the the y-intercept, it's a little bit less work. So negative x plus 2x, that gives you plus x minus 2. Okay, so the domain, all x such that x cannot equal 1 or negative 2, because that's what would make the denominator 0, those two values. No holes because there are no common factors. X-intercept, we look at the numerator. What makes it 0 is 4. Y-intercept, again, cover up all the x's. So this one, oh sorry, let me go to this side. This one and these two, so we're just left with negative 4 over negative 2. So that's 0, 2. Vertical asymptote, there are two of them, x equals 1 and x equals negative 2. Now the reason I like having the version that's not factored, so that for comparing the degrees, I think it's a little bit easier to see it in this form versus this form. So here the degree is 1 and here the degree is 2. It's a little bit more obvious than looking at this one. Okay, so this is a bottom heavy, so y equals 0. As for symmetry, it's neither, it's or none, because you replace the x with a negative x and you do not get the same function back, nor do you get the opposite function back. Okay, so I went ahead and I placed the asymptotes and the 2 points, the 2 intercepts. So now I'm getting ready to graph the actual curves, right, the function. So I know that the middle section has to open up like this, because there's no way it's going to cross, it can't go down, right, because it cannot cross the x-axis at all. This is the only point where it could cross the x-axis, and it can't cross over this way because I've got a vertical asymptote right here. So it has to go like this, it has to. Over here on this side, it could either do this where it crosses over, or it could do this like this where it crosses like that. So in order to determine which one it is, I'm going to pick a value. So let's just say 2. So I'm going to do f of 2. So again, it doesn't matter which form you use, I'll just use the one that's factored. So 2 minus 4 is negative 2. 2 minus 1 is 1. And 2 plus 2 is 4. So I get negative 1/2, negative 2 over 4. So that's all I need, right, to know that at 2 it's going to be right here. So then that means the curve is going to go down like this. It crosses here at 4, and it still stays close to the asymptote. Okay. Like we said before, it's going to go up here and up here. Okay, it's not like a parabola, so it's not a symmetric curve. Notice the left side has more space than the right side from the from the y-axis, so it's not a symmetric curve. On the left side, I'll pick let's say negative 4. So f of negative 4. So negative 4 minus 4 is negative 8. Negative 4 minus 1 is negative 5. And negative 4 plus 2 is negative 2. So that's going to give me negative, what is it, 4/5? Negative 4/5 when you reduce this and simplify. So negative 4 is negative 4/5, so that would be about right here. So again, that's all the point I need to draw this curve.